Okay, physics. So I wanted to talk with you about how to use calculus really to your advantage. So some of the handy things that we can do with it. In particular, we can get at inflection points and extreme points, a way to help us interpret graphs from really complex things. So let me start with it, and let me walk you through an example of what this might look like. So where'd it go? There it is. So suppose we have a position graph that has some really gnarly function, right? So t to the fourth minus t cubed minus 7t squared minus 8t minus 8. Whew! Ugly. So, so this is some kind of graph. I don't know what it looks like, but we can start to figure that out, and we can find out really important points on this graph with, if we're careful about it. So here we go. So one way to interpret this is, well, let's just plug in some numbers and see what it looks like. So I'm going to say, well, what's x at 0? Right? So I plug in 0, and I'm left with minus 8. What's my position at time equals 1 second? Well, I don't know, but it looks like minus 21. And we do the same for a few more, and we can kind of get a feel for this graph and how it's behaving. And so far, pretty consistent, but then it's going to change. Now I'm left with at 3 seconds, it jumps into the positive side. So this graph is going to have some shape, and there's going to be a change in there. And this is a change in direction, right? So look what happens. So I start out in my negative direction, going pretty quickly. I must slow down in my negative direction and then speed up in the positive direction, right? So there's a change in direction that happens in this position graph. Let's start to take a look at what this kind of looks like. So we can switch to a graph. So I can plot these 3 points on or 4 points on a graph, and we get something that kind of looks like this. But you know, it's hard to pick out, right? So what's happening here at the at 2 seconds? Is that the bottom? I don't know. So we can use calculus to figure out, you know, how low does it go? So what is the bottom point? And remember, calculus is just a way of helping interpret graphs, really. So my derivative is going to tell me the slope, or the slope of the tangent line. So, and my integral is going to do the reverse, tell me the area under the curve. So we can use derivatives here to try to interpret a few things about this. So what I'm interested in knowing is, well, how low does this go? So what's the inflection point? Or another way to phrase this in terms of calculus, I say, well, where in here does my slope become 0? And what that means to us is, well, we can take the derivative of this equation and we can set it equal to 0, and we can get an answer to that. We can figure out when it is 0. So let's do that. So let me go back. Go back here. So we're going to take the derivative and set this equal to 0. So I'm going to say, well, my velocity anytime, I want to set that to 0. So to do that, I'm going to take the derivative of all of this, okay, with respect to time. That's a t. Respect to time. And remember how I do this. So I'm going to multiply by my exponent and then subtract 1 from my exponent. So I'm going to have 4t cubed. I'm going to multiply by my exponent and subtract 1 from my exponent. And the same, 14t minus 8. And then this one gets dropped off. All right. Well, what is this going to look like? That's a little bit hairy, but hopefully you have a calculator or some means of solving this. I'll help you get started here. So I'm going to factor out t plus 2. And this is going to leave me 4t squared minus 5t minus 4. So I'm going to set this equal to 0. So hopefully you should be able to take it from this point, right, that I know at when this is 0. So it's just telling me when my velocity is 0. So think about this, right? You throw a ball up, it has positive velocity, and then it has negative velocity, but instantaneously it's going to have 0 velocity. And that's what we're doing. We're finding what's that point. We're just throwing it down in this case, but it's the same idea. So it turns out, right, t can be velocity can be 0 at minus 2, can be 0 at minus 0.55 seconds, and it can be 0 at 1.8 seconds. So hopefully you'll be able to look at this and recognize, well, negative time. We don't do that. We don't do that. So so those two are not going to be good. So it looks like at 1.8 seconds. So I can plug that in here back to my original position equation, and I'll discover that the position at 1.8 seconds comes to something. What did that come to? I don't know. I'll plug it in and see what we got. So 32, I think it was 32 and a 32.4. So let's add this to our graph. Right? So and it should make sense, right, that so I've added in this time point, that this is now the lowest point. So right, we took the derivative and we set that equal to 0. So it tells us right at this point, this is my extreme low point, that my slope there is 0. Second thing that we're interested in doing is finding the inflection point. So think about this graph. So it starts out, it's accelerating in the negative direction, and then it starts accelerating in the positive direction. So there's a change in acceleration. So my acceleration went from negative to positive, so we can find out where that happened. And in calculus, how we're going to do that is we're going to take the derivative, or the rate of change of velocity, and set that equal to 0 and see what we get. So let's do that as well. So now I'm going to repeat the same thing. I want to find out what's an equation for my acceleration at any time point. So I'm going to take this equation for velocity. I'm going to take the derivative of that. Right, I'm going to take the derivative of this, and I'm going to set that equal to 0. So let me take the derivative. So again, I'm going to multiply by 3 and lessen the exponent by 1. I'm going to multiply by my exponent, multiply by my exponent. So, so this is a quadratic, so you need to be able to solve those. And when you solve that, you're going to get two answers. You're going to get negative 1.36 seconds, and you're going to get time is equal to 0.85 seconds. So hopefully you recognize negative time is not going to work. So we're going to have a new data point. So I can plug in that 0.85 seconds into my equation and find out what is the position at that time. And there it is. Right? So now you get a better shape for the graph. So, and we have two key points on there. So this lowest point is where the velocity changes from negative to positive, and this other point that we just plotted, that's where acceleration changes. So we'll call that the inflection point, or the second derivative. So that's where our acceleration changes from negative to positive. And there's other stuff, right? So if we shifted the graph over, we'd have more than one inflection point and more than one extreme point. So you may end up with more than one point on the graph, but you'll know which one is the most important one for you when you look at the problem. Anyway, I hope that's helpful. So two things that we do with calculus that helps us get to specific points. We're interested in changes in either direction or changes in acceleration. Hope that's helpful. We'll talk to you soon. Bye.